All right, guys. So we're just running through questions over here from the prelim. From the modeling part, so if we have a look at this question 4 over here, it says caracals in a certain, there's a caracal in a certain game reserve have 2 litters per year, with an average litter size of 3 kittens. 60% of the population is female. The survival rate is 70%, and the average caracal lives for about 8 years. So calculate the annual growth rate, or the intrinsic growth rate of the caracals correct to 3 decimal places. So in the Malthusian model, intrinsic growth is equal to birth rate minus death rate. So to figure out the birth rate is equal to percentage females times by number of surviving offspring. Okay, so the percentage females, you can just use the percentage button on your calculator, is 70%. Okay, in 1 annum, okay, because it's an annual growth rate, the number of surviving offspring, okay, well, each female has 2 litters per year. In each litter, she has 3 kittens, so she has 6 kittens per year. Of those, 70% survive. Okay, so if you stick that into your calculator, okay, you should get an answer of 2,52. Okay, so that's going to be your, that comes up a lot, your birth rate, percentage female times number of surviving offspring. Okay, then your death rate, well, your death rate equals 1 over life expectancy, in other words, 1 over C. And your life expectancy for a caracal is 8 years. So your death rate is 1 over 8, which in other words, you'd expect 1 out of every, in a year, you'd expect 1 out of every 8 caracals to die. Okay. Right. So then you figure out the growth rates are, so your growth rate R is equal to birth rate minus death rate. So R is equal to your birth rate is 2,52, and your death rate is 1 over 8. And if you put that into your calculator to 3 decimal places, you get an answer of 2,395. In other words, 39.5%, which is a ridiculously high value, and is really not realistic. So sometimes I ask questions like that. They say, is this a realistic growth rate? And in something like a caracal, it's definitely not. Okay. But the next question says, okay, express the growth rate of the caracal population as a recursive Malthusian model formula using an annual growth rate of 2,4. So we often do that. Well, we set exam questions so that you don't go make, we can see that that has to be 3 decimal places. So if you just wrote 2,4, we take off 2 marks because you just used the previous question. But we don't want to penalize you for the next question. Okay, so that's why we give you that answer over here. So we've got R is equal to 2,4. Okay, the Malthusian model formula you're not given. Okay, but it's just percentage increase. So P to the N plus 1. It's a recursive formula, remember? Okay, well, it's equal to R. That's your increase in your population. Okay, if you want to understand the formula, plus the original population. And that factorizes to P to the N plus 1 is equal to P to the N R plus 1. Okay. And in this case, R is equal to 2,4. So P to the N plus 1 is equal to P to the N 1 plus 2,4. And if you want to make it prettier, P to the N plus 1 is equal to P to the N 3,4. They haven't given us the initial population, so we can't put it what P naught is equal to. Right, 4.2 done. Okay, then 4.3. Okay, calculate the caracal population of the 10 years in this reserve if there are currently 12 caracals living there. So now they give us P naught is equal to 12. And they remind us again that we must use an intrinsic growth rate of 2,4. So our formula is P to the n plus 1 is equal to P to the n 1 plus 2,4. In other words, P to the n plus 1, as we said in the previous question, 1 P to the n, P to the n plus 1 is equal to P to the n 1 plus r. So in other words, 1 plus 2,4, in other words, 3,4 Pn. Okay. Right. So now you're just going to get your calculator. Okay. And on your calculator, you're going to enter your first value. So you're going to go 12 on your calculator. You're going to go 12 equals, clear your screen. Now that has been stored in your memory. Okay. So on your calculator, you're going to go 3,44 okay, times by your answer equals, okay, and you should get okay, a P naught is equal to 12, right? So so you're going to 12 equals, so 3,4 times 12, and your first answer should be 40,8. Okay, so that's, I would always write down, sorry, I lost focus for a second there. Okay. So 12 is stored in your calculator. So P naught was equal to 12. I would always write down the value of P1 just so you can show the marker you're getting it right in case you count incorrectly. So you get P1 is equal to 40,8. And then you keep pressing equals on your calculator. You go equals, 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 equals. It's for 10 years. So you press the button 10 times and you should end up with P10 is equal to 2,477,253. At this point, they would often say to you, is this a realistic number? Well, to think of if it was insects, perhaps, but caracals, to grow from a population of 12 to that is entirely unrealistic, really. Okay, so there's something fundamentally wrong with this model as it stands. Right, so the next question wasn't done too well, okay, because you didn't understand the concept, okay, of changing interest rates. So it says, to prevent the caracal population from growing too fast and causing too much damage, a culling program is done on a fortnightly basis. So they are killing caracals every 2 weeks. When you are taking away those caracals, this is inflexible. This has to be every 2 weeks. Okay, so we are working in a 2-week time period. It has changed from an annual time period. The problem is at the moment, my interest rate, okay, just like in finance, is in terms of per annum. So at the moment, R is equal to 2,4, in other words, 240%, okay, per annum. Okay, but just like in finance, you have to get your interest period, okay, into the same time reference as when your deposits are or your withdrawals are being made. So we have to get things, okay, this is an effective interest rate. So we know that R effective, okay, is equal to 2,4, okay, or 240%. But we need to get this, the caracals are being taken away every 2 weeks. It's like a deposit in finance. It's being made every 2 weeks. So we need to get this to, the notation we use is I-26 if you want to use it like that in finance. Okay. We want to get this to a nominal interest. In other words, per annum. We want to end up with an answer of per annum compounded fortnightly or every 2 weeks. Okay, so how many 2 weeks are there in the year? That's why I use 26, right? Okay, and if you look on your formula sheet, there's a formula which says R effective. It's the same actual one that we use in core, but you're not given it in core and you use slightly different notation. Okay, so R effective is equal to 1 plus R nominal, okay, over K, and K represents the number of times, okay, you're going to collect interest in a year, okay? So over K, all to the power of K, okay, minus 1. The same thing as 1 plus I is equal to 1 plus, in core we use this. Okay, But this is the same thing as R effective. So you end up with I is R effective in this notation is equal to 1 plus I nominal. This is what we mean by I nominal over M is the number of times you collect interest in the year. So you end up with the same formula, 1 plus I to the M over M to the M minus 1. Okay, so we know that R effective is equal to 2,4 or 240%. So 2,4 is equal to 1 plus, we're looking for R nominal fortnightly. So there are 26 fortnights in a year. So it's over 26 to the 26 minus 1. Now you have to make R nominal the subject of the formula. So to do that, we're going to go 2,4 plus 1. So you're going to have 3,4. And then you're going to get rid of that 26. So you're going to go the 26th root of 3,4. Okay. And we're going to be left with 1 plus, you don't have to show the step, showing you what we're doing. Okay. Then you're going to move that 1 across. So you're going to get the 26th root of 3,4 minus 1 times 26 is equal to R nominal. Okay. And if you put that into your calculator, okay, you should get an answer. Okay, so 3,4 R effective is equal to 2,4. What did I say? Okay, no. 2,4 is equal to 1 plus R nominal. I'm just taking the memo of 26 minus 1. Okay, so you're trying to isolate. Yeah, that's right. So square root of 3,4 to 26 minus 1. Yep. Okay, all multiplied by 26. So you should get an answer. The nominal interest rate is equal to 1,253. Okay. In other words, 12.53%. Okay, per annum. What have we worked out? The interest rate per annum compounded fortnightly, 26 times in a year. So now, so you cannot change when you're taking away these caracals, just like you cannot change when you're taking away, putting money in or etc. like that. But we can change the interest rate to reflect the same time frame as when the deposits or withdrawals are taking place. Okay, so now I've got the right interest rate. Now the question says, okay, calculate the minimum number of caracals that need to be killed every fortnight to keep the present number of caracals approximately constant, use an annual rate, blah, blah, give your answer correct. So now we want the population. Okay, I should have perhaps made it a bit clearer. So it says to keep the present, by the present number, some of you got confused, but I marked that correct, whatever number you used. Okay, I would have said if I wrote this, I would change this question to keep the present number of caracals at 12. Okay, so we want to keep the population constant at 12. But to keep the population constant at 12, okay, well, I'm using a Malthusian model. So I've got p to the n plus 1 is equal to p to the n 1 plus your nominal interest rate, because now the whole thing, remember, is in fortnightly. Okay, so we've got to use our nominal interest rate. Okay, so 1 plus our nominal minus x. And where x is the number of caracals you have to remove to keep the population stable. But if I want to keep it stable at 12, those two must both be equal to 12. So you're going to get 12 is equal to 12. 1 plus the nominal interest rate we worked out was equal to, okay, 1,253. Okay, so it's going to be equal to, okay, our nominal is equal to that. So it's going to be 1 plus 1,253. 12 is equal to 12. 1 plus 2,53, yeah, that's right. Okay, 1 plus 1,253. What about that? Okay, 1 plus the normal interest rate is 1,253. Okay, 1,253. Okay, over 26. Okay, minus x. Because the nominal interest rate, if it's the nominal interest rate is per annum compounded fortnightly, you have to divide by 26. If it's per annum compounded monthly, remember if you had a finance sum, and I said you got 50,000 Rand increased at a rate of 10% per annum compounded monthly. Okay, and I said, how much would that accumulate to? We've got A is equal to P 1 plus I to the N. So A would be 50,000. The interest rate you'd use is 1 plus 10% over the amount of interest you get in a month would be 10% over 12. So here, the amount of interest you get in a year is 1,253, okay, divided by 26, okay, minus X. So you end up with X is equal to, and if you go that, minus 12, you should get an answer of 0,578. So if you round it to the nearest caracal, you get X is equal to 1. So in other words, kill 1 every fortnight. Kill 1 every fortnight. So always check your frame reference. Okay. All right then. Okay. Okay.